Welcome back. What did Batman say to Robin before he got in the car? Robin, get in the car. Okay. We talked about exponentials. Guess what we're going to talk about now? Yeah, logs. All right. And of course, base E, also known as a natural log. That's why it's kind of ln, maybe log natural. It's just log base E of x, or kind of like ln x. They're the same kind of thing. Just a reminder, it's the inverse of an exponential. If you do expansion, if you do extension, it means that you swap the x's and the y's. And so, all your x's become your y values, or your y values become your x values. For those of you guys in advance, the easiest way to picture it is it's reflected across the y equals x line. So you can see here in the top left, you've got your exponential, and then there's your y equals x line. And then so your log will be a perfect mirror image of your exponential. Okay, and that's what your ln x is. A couple of things to note here is never happens in the negative, doesn't exist in the same way that your exponential doesn't go negative. Your x's don't go negative for your logs. Also, the y-intercept is 1. So that means the x-intercept of your log is also 1. And that is your base function. That's the main graph that we have before we start transforming it, moving it left, right, up, down, reflecting it. That's your basic. Okay, so don't forget it. A couple of things to note here. If we're talking about the domain of a log is x must be greater than 0. Okay, or there you go. I already wrote that. Look at that, prepared. So now if I'm talking about the transformations, let's talk transformations. And because I've got the magic of the iPad, here's what I'm going to do. I'm going to draw what a log would normally look like, and then I'm going to try my best to move it. Okay, so if I've got +1, guess what? I move my point. Normally I know I cut through 1, 1, 0. So now I'm actually just going to move it up 1 to this point here. And that is it. That's all I need to do. Boom, move it up. Move this little guy too. There you go. That's it. Now, if I've got this graph here, again, I'm going to try and draw it just like this. That would be my regular log graph, but this +1 is a horizontal 1 to the left, right? I'm hoping that you guys remember that. So I know this point, I'm just going to move it 1 to the left. And there it is. And so a couple things to note as well is my new asymptote is now at y equals -1. Okay, that's cutting now at 0, 0. Boom, there's your graph. If I have log e of -x, normally we look like this, but now it's actually going to look like this way, because that -x means we reflect it across the y-axis. There you go. Okay, so it's still going to cut at -1. That's what our graph is going to look like. And if I make the whole thing negative, that means I reflect it across the x-axis. So if my original kind of looks like this, the way that my new version is going to look is it's going to look like this. Okay, not perfect, but it's somewhat going to look like that, and it's still going to cut through 1. Okay. Now, talking about your log laws, I've written them all here. These are just the same log laws that we've done a couple lessons previous, just with base E this time. Now, what you'll find is I'm pretty sure you will have to do some log laws, including the E's in this exercise that you're doing. Watch back on the other video if you've forgotten how to do this. All right, that's it. Good luck. All the best, and bye-bye.